Students, so now we are continuing with the module 4 of Geotechnical Engineering II. So initially in previous lecture we have discussed about initially in the previous lecture we discussed about various types of foundations and especially the combined footing. So what are the scenarios where we opt for a combined footing? All those things we discussed. Now we will do two simple problems. These are university questions as well. Such questions are asked for university exams, around 12 to 8 marks questions. So there are two types of combined footings. One is a rectangular footing and another is a trapezoidal footing. Already I just gave a brief idea in which situation you will go for a rectangular footing and when will you opt for a trapezoidal footing. So now let us do this problem, and in this problem along with the problem I will be explaining the various steps involved in the design of a footing, so that part also you will be clear while doing this problem. So this is the question: compute the planned dimensions of a rectangular combined footing for the following column loads and details. The cross section, the center to center distance between the column is 5 meter. Column 1 is at the edge of the footing. Take allowable soil pressure as 100 kPa. Now these are the details of the column. Column 1, the load coming on column 1 is 600 kilonewton and the load coming on column 2 is 900 kilonewton. This is the dimension of column 1, 0.3 by 0.3, and the dimension of column 2 is 0.4 by 0.4. So you will be given a question in this manner. You will be given the loads coming on the columns, the dimensions of the columns, and the center to center distance between the column, and here it is asked that it is a rectangular combined footing. So you have to directly find the dimensions of a rectangular footing. In some cases, generally question can be asked in this way also, like they will be giving you the center to center distance as well as the column loads and the dimensions, and based on that how will you decide whether you should provide a rectangular base or a trapezoidal base. So that part also will be discussed in this problem. So moving on to the solution, first you need to find the total resultant load coming onto the footing. So here what I am doing is, already it is mentioned that the column 1 is at the edge of the footing. That means that will be the boundary wall. So we take it as the exterior column, and let us take column 2 as the interior column, because they are not mentioning anything about column 2, but they are saying that column 1 is at the edge of the footing, that is, it is at the almost at the outer side of the footing. While seeing the figure you will get a better understanding. So first step is to find the total loads coming onto the footing. So what are the total loads? First column it is 600 and the second column it is 900. So find the total load. I am giving here load on column 1 as Q1 and the load on column 2 as Q2. So the total load is Q1 plus Q2. So you get the total resultant load as 1500 kilonewton. Now you are given the allowable pressure, that this must be the allowable pressure on the soil, this is 100 kPa. So you are having the total load of 1500 kilonewton. So if you have the allowable pressure and the total load, you can find the area of the footing, the tentative area I would like to say, because after slight modifications this pressure may change the actual pressure. So this is the allowable pressure. So from the net allowable pressure you find the area is Q by Qna. You know that net allowable pressure is load by area, so you find the area using this expression, Q by small q Na, where small q Na is the net allowable soil pressure, and here it is 100 kPa. Now just make a sketch like this, because you don't know the dimension of the entire rectangle, because you only know the spacing of the columns and you have the size of the column. So just make a sketch like this. See Q1, here it is at the edge, this red line you can say let this be the boundary. So this is at the edge of the footing base, Q1. I just marked this and marked it in red so that you can understand this as the boundary wall. Now this is the large column Q2 at a distance, center distance of 5 meter, already given in the question. I have marked the dimensions of the columns. This is the bigger column, this is smaller column, and this is the size. I just showed it as B1 by B1, that is the size of this column, and this I gave as B2 by B2. That means 0.3 by 0.3, 0.4 by 0.4. Just for understanding, I have given it in this way. Now you have the area, you have the load 1500, you have the allowable pressure 100. So from that you get area as 15 meters square. So you have an area of the rectangular base. So now you have the area. Now how will you fix the length and breadth of the footing? So for that you have to find the line of action of this resultant column load. So the resultant column load is Q, that is where this 1500 is acting on the footing. So for that you use this expression, you find it from the exterior column. Just take moment about the exterior column, or you can just take moment about this center point where this Q1 is acting. So you get x bar is equal to Q2 x2 by Q. We have Q2 900, x2 is 5, already the spacing is given, and then Q is 1500. You get x bar as 3 meter. So here is the point where x bar is acting. So I've just gave a section here, and this is the point of action of the load Q at a distance of 3 meter from the point Q1 where Q1 is acting. So already I have mentioned that whenever x bar is equal to L by 2, or in a situation where it can be more than L by 2, then we can go for a rectangular footing, and whenever x bar is less than L by 2, then we can go for a trapezoidal footing, provided that x bar must be greater than L by 3. That I will explain when I am doing the problem related to trapezoidal footing, which is the next problem. So we have x bar as 3 meter. Now anyway you need not worry about the conditions here, because you are already given that it is a rectangular footing, so you have to design accordingly. Okay, so how will you find the length? This is the expression to find the length, that is L equal to 2 into x bar plus B1 by 2. Here I am just considering the exterior column. I have started everything from the exterior column, so that way also you can do. You can consider, here it is mentioned that it is the exterior column. You can start from this side also, but it's always, it won't create any confusion if you start from the left side. That is why I have started it from the exterior column. It is recommended that you also do this way. So to find the footing length of the footing, just use this expression, that is x bar plus B1 by 2 into 2. So that is the expression for length of the footing. So B1 is the size of the column, this first column, because I have opted here for the first column. You can also consider this as B1, but I have taken this column. But you also follow the same procedure. In textbooks also they always start from the exterior column if the exterior column is already specified. So L is equal, this is a standard expression. Length of the footing base is 2 into x bar plus B1 by 2. So B1 here is Q1. So for column, the dimension of Q1, that is 0.3. X bar we already found out as 3. So 2 into 3 plus 0.3 by 2, get length of the footing as 6.3 meter. Now you have the area as 15 meters square, already we have found that. So you need to find the breadth as area by length, which is 2.4 meter. Now there may be slight differences in the length and the breadth as we are rounding off these figures, that length and width. So actual pressure need not be always same. Maybe it may be less than 100. Here the allowable pressure is 100. So for that allowable pressure we have found the area of the footing, but due to rounding off it may not be equal to the actual pressure. So you have to find the actual pressure Q naught corresponding to this area, what is coming now, 6.3 into 2.4. So using this actual area, actual pressure, sorry, this is actual pressure. and the actual pressure Q naught, because I told you due to rounding off area may change slightly. So you find the actual pressure, and based on that actual pressure you have to find the shear force and bending moment. So you have the loads, you have the pressure, and based on that you find the shear force and bending moment and design means you have to design the depth of the footing as well as the reinforcements and all. So for that you need to find the shear force and bending moment. But as far as exam point of view and your syllabus, you need to find only the dimensions of the footing. So your job is finished here. Once you find the L and B, your job is over. But still I am just continuing with the actual procedure. So this is what you are getting. Here x bar is equal to L by 2 almost, like L is around 6.3 and we got x bar as 3, so almost it is equal to L by 2, just take it that way. And anyway they have mentioned that we have to design a rectangular footing, so it is irrelevant whether x bar is greater or less than L by 2. But generally if no condition is mentioned and you are asked to find just a asked to design just a footing, then you have to see this condition whether x bar is equal to L by 2 or it is less than L by 2. If you get exactly x bar is equal to L by 2, then you have to definitely design a rectangular footing if nothing is specified. So this is how the front view of the foundation will be looking. This is two pedestals where the column nodes are acting, and this is the base of the footing. So already you have designed the base. The width is 2.4 and the length is 6.3. So this is at the edge, so you can see that this one will automatically come into the interior side of the footing. Already this is specified that it will be at the edge, so be careful when solving such questions. They may say that both the columns are at the edges of the footing, or maybe they will give that clearance outside the footing 1 is or column 1 is like 0.2 meter and column 2 is like 0.1 meter. So the sketching part must be clear, then only you will be able to find the exact dimensions. So this is how this sketch is very important. After finding all the dimensions, you have to make a sketch like this. So moving on to the design procedure, already I told you that you have to find the Q naught. So corresponding to the Q naught, you will be designing the reinforcement as well as the depth of the foundation base. So for that you will draw the shear force and bending moment diagram for the Q acting on the footing as well as the pressure you have found out, the upward pressure. Actually this the load is acting downward and the soil pressure is acting in the upward direction, which is Q naught, which you have found out the actual pressure. So for that particular pressure and the loading, you will be finding the bending moment and shear force, and always the thickness is designed for the maximum bending moment. So thickness of footing is designed for the maximum bending moment, and also you find the position where there is maximum bending moment, and for that you will be designing the longitudinal reinforcement, and also you will find the bending moment in the short direction to provide the transverse reinforcement. So you need not go in too much in the details. This detailing portion is not there. Usually the questions are asked only to find the dimensions of the foundation. So if you are interested to move further, this is the pressure diagram. So actual pressure is Q naught. So Q naught we have found it in kilonewton per meter square. So in running meters you just divide it with the length of the this length of the footing. You get it in terms of, multiply it with the length of the footing, you get it in terms of running meters. Okay, that is 238.1 kilonewton per meter. Now for this corresponding pressure diagram and this loading condition, you find the bending moment diagram as well as this is the shear force diagram as well as the bending moment diagram. Already you have learned all these things in your previous semesters. So just if anyone wants to try, you can just find the bending moment and shear force diagrams, which are finally used for the design. But exam point of view, you have to only find the L and B of this footing, and you have to finally show this sketch. So that is about the rectangular footing. Now moving on to the trapezoidal footing, it is The procedure is similar but slightly different, as the dimensions are different, so another kind of dimension. So for that the equations are, you have to apply is different, but the entire procedure is the same. So this is a question for trapezoidal footing. Here you can say that the question is asked just to design a combined footing. So you are not, they are not asking you to either go for a rectangular or trapezoidal. So you have to decide on your own whether you have to provide a rectangular footing or a combined footing. So this is a question. Compute the planned dimensions of a combined footing for the following column loads and details. The center to center distance between the columns is 6 meter. Both the columns are at the edge of the footing. So already this part is clear. You can either take column 1 as the exterior column or column 2 as the exterior column. It won't make any difference because both the columns are at the edge of the footing. Now take allowable soil pressure as 200 kPa. Column 1, the load coming on column 1 is 2000 kilonewton and load coming on column 2 is 1500 kilonewton. The dimensions of the columns, for 1 it is 0.5 by 5, again for 2 it is the same dimension. So here also I am just starting from column 1. It is, you need not start from column 2 or column 1. Nothing specific is there. So let us again, I am just in the similar to previous case. Here also I am just starting with column 1. So the first step is to find the total load. Load coming on column 1 and column 2 is already given. Find the total load. Total load is 2000 plus 1500, which is 3500. Now find the area. You are given the allowable pressure 200 kPa. So using that you find the area. A equal to Q by QNA. So the area is 17.5 meter square. Okay, some mistake is there. This is 200. Okay. So area you have found out. So until now it is the standard procedure similar to rectangular footing. Now here already you know the length of the footing because the center to center distance is already given and the size of the column is given and already mentioned that both the columns are at the edges. So the total length is 6.5 meter, 0.25, the half of this column, 0.25 center to center distance, this portion 0.25 plus 6 plus 0.25, that is 6.5 meter. So how will you find the line of action? It is the same equation. X bar is equal to Q2 X2 by Q. You take moment about the center where this Q1 load is acting, here from here. So Q2 X2 by Q, you get X bar as 2.57 meter and L by 2 is 3.15. So this value is less than L by 2. So then definitely you will have to go for a trapezoidal footing. So this is the condition. Actually already you know X bar is less than 2, but still you have to find X dash. What is X dash? X dash is actually the distance between the from the edge of the footing to the line of action of Q. So X dash also you have to find out. Anyway, you have found X bar. If X bar is less than L by 2, definitely X dash can also be less than L by 2, but generally may not be the case. So here for a trapezoidal footing, make sure that you find the X dash, that is the distance from the extreme end of the footing. So that is X dash is equal to X bar plus half of this column width, that is X bar plus B1 by 2, which is 2.82 meter. This was not done in the rectangular footing, and this has to be checked only in the trapezoidal footing, because what if you have a very big column? So maybe in that situation it may go it may be higher than L by 2 or equal to L by 2. So you need not design a trapezoidal footing in that case. So here you find the X dash, that is 2.82 meter, and still X dash is less than L by 2. So L by 2 is 3.25 and L by 3 is 2.17. So this is the condition for a trapezoidal footing. You find the X dash, and if the X dash is between L by 3 and L by 2, then you have to go for a trapezoidal footing. So for a trapezoidal footing you have to find the X dash, keep that in mind. But for a rectangular footing, directly from X bar, and if you find the X bar and also you find that X bar is equal to L by 2, then you can go for a rectangular footing. But when it comes to a trapezoidal footing, not only x bar, you will have to find the x dash as well, and this x dash must be between L by 3 and L by 2. Then only you can design a trapezoidal footing. And again, if this x dash is moving is further less than L by 3, then it is a different case where you go for a strap footing. Already I have discussed what is a strap footing. So that footing is provided when the x dash is less than L by 3. So if nothing is mentioned, then you have to be very careful with these conditions. So based on the conditions, you have to design the footings. So here it is definitely a case of trapezoidal footing. So now let us move on to the design part. So already you have the length here, it is 6.5. So only thing left out is the width. That is, you know that trapezium has two widths, B1 here and B2. Two widths you have to find out. So this is the expression for B1 and B2. So what is B2? B2 is 2a by L into 3x dash by L minus 1, and B1 is 2a by L minus B2. So these are the two expressions used to find the widths of the trapezoidal footing. Length already you are given. So using this expression, I got B1 as 3.76 meter and B2 as 1.62 meters. So this is how you find the dimensions of the trapezoidal footing. Now another interesting part is, here as the widths are different, that is your B1 and B2 are different, the pressure will also be different. That is, you have a varying pressure here. You have maximum pressure at the outer this side, that means where B1 is the width, and you have minimum pressure at the B2 when you take it in terms of kilonewton per meter. So this is the varying pressure distribution, and also you have the loads. So based on that, you find the bending moment diagram and the shear force diagram, and accordingly you can design the reinforcement as well as the thickness of the footing. So again, I am repeating that you need not go to this, because as far as exam point of view is concerned, always the questions are in this fashion, that you will be asked only to find the planned dimensions of the footing. So don't waste time going for the diagrams, the bending moment diagram, shear force diagram and all. I am just showing this for your understanding that this is not the ultimate procedure. You have to move further to find the design. So don't get confused with that part. Okay. So that is all for today's lecture. Thank you.